So I'm going to tell you a success story for property-based listing. And I'm going to kick off with a quote from Claessen, which was on the Erlang mailing list a few years ago. We know there's a lurking bug somewhere in the dets code. We've got bad object and parameter end of the file every other month for last year. We've not been able to track the bug down since the file is repaired automatically next time it's open. So even those who aren't familiar with the context here will feel their hearts bleed at this point. Poor Tupper. This is a nightmare situation. Let me just explain the context. Claessen is a Swedish company that offers services for web shops, and it's grown to 400 or 500 people. Is that still right, Eric?
Yes, so something like that.
In about 5 years. So it's a rocket in its application area. It's a really great idea. And the application is built using Erlang. The data is stored in mnesia, the database that comes together with Erlang. And that provides distribution and transactions and replication and so on. Mnesia, in turn, keeps its data in dets. Disk Erlang term store, which provides tuple storage, and dets keeps those tuples in a file. So this is the component that is giving trouble. And I thought this was an interesting bug, because when something crops up in production every month or two, it sounds as though it could be a race condition. And I was interested in race conditions at this time. So let me just introduce the technique that we used. This is a technique that we published at ICFP a couple of years ago. And I'm going to kick off with a very trivial example. Just imagine you're testing one of these things. Now, in Sweden, we have very many of these because we are the world's best at queuing. Every delicatessen counter in every supermarket has one of these. And when you come along, you just take a ticket, and they have a machine at the back that displays the next ticket number. And when it's your turn, you get to buy stuff from the depot. But just imagine that I was going to try and implement one of these things in Erlang. Well, I'd need a couple of operations in an API. I'd need to be able to take a ticket, of course. And sooner or later, the row of tickets runs out, and then I need to put in a new one. Let's call that reset. I'm not going to show you my implementation of this. I'm going to consider testing it. So, of course, we could all sit down and start writing unit tests for it. I've not used the unit notation here, but we know the idea even so, where we perform some sequence of calls and we match the results against expected values. And as we know, this is the standard approach to writing unit test cases. That's easy enough. But wait a minute. What is the point of a ticket dispenser? It's there to regulate the flow of a lot of concurrent customers to one delicatessen counter, right? So, what is the point of writing sequential tests? Of course, I want to test its concurrent behavior. And unit tests like this don't do that. What I want to do instead is to run tests that maybe look more like this, where I start off by resetting the dispenser, and then maybe one customer comes along and takes 2 tickets, because he wants cheese and ham, and another customer comes along and takes 1 ticket. So now imagine writing a unit test looks like this. What are the expected results? Well, we could get OK from reset, this customer could get 1 or 2, and the other customer could get ticket 3. But it's not certain that that will happen. It might be that this customer gets tickets 1 and 3, because in between taking those 2 tickets, the other customer got in and snatched ticket number 2. That's also okay. If we get those results, the test is passed. But if we get these ones, where both customers get ticket 1, then something has gone wrong. So, as you can see, it's going to be harder to write a unit test for this kind of behavior. In this case, there are 3 possible correct outcomes. So what you could do is you could record the 3 tickets and then just compare against the 3 possibilities. same time as the serviceman is changing the roll of tickets. How many possible correct answers are there for this test? I've worked it out. It's 42. Nobody in their right minds would try to work out all 42 possible correct outcomes and then compare against all of them. And anybody who did try would get it wrong. So you just can't write conventional looking unit tests that test this kind of behavior. Okay, in comes property-based testing to the rescue. What can we do instead? Well, if we can't enumerate the correct outcomes, we have to recognize them some other way, like by writing a property that can distinguish the correct answer, or a correct answer, from wrong answers. In the first case, I could take the 3 ticket numbers maybe and sort them, and see have I got tickets 1, 2, and 3. That's one property I could use. It's not the best, but that would detect the particular error that I showed you. But what I'm going to show you instead is that we can generate tests with QuickCheck, so we have a wide variety of tests, and we can use a model to decide whether the test has passed. Quick introduction to state machine models, which we've already seen a little bit about this afternoon. The approach that we take is that we generate test cases that are a sequence of API calls. We also model the state of the system on the test, and we define how the model state changes as each API call occurs. And then we write post conditions that compare the actual results of each API call against the model state that we think we're in. And that way we can discover if there's an inconsistency. In this case, the test case for the dispenser might look like this: reset, 3 ticks. And we can model the state just by an integer. So here's the model state at each stage. It's the state before a call. So after a reset, the state is 0. After the first ticket, the state is 1. And then we can just write a post condition to compare the actual results, here they are, against the model state. So if we call take in the state of 0, we get 1. That's correct. And so, indeed, the dispenser will pass this kind of test. Now, what I've shown you here is obviously a way of generating and running sequential tests. The wonderful thing is that once we've built the model that can do this, we can use it for parallel tests too. Here's how we do that. We simply generate tests that start off with some sequence to put the system into a random state, followed by one or more concurrent processes that also perform sequences of calls. So here's the first test case that I showed you, drawn on its side. So how can we tell whether or not the actual results that we've got here, 1, 2, and 3, are correct? Well, we can do so just by seeing, can we find an order in which we could have executed those calls that's consistent with the concurrent structure of the test, such that when we rearrange the calls into that sequence, the model says that all the post conditions are true. If so, the test is passed. Or perhaps, to be more precise, if not, something has certainly gone wrong. And that's how we can recognize failing tests. How am I doing?
Experiments.
Great. When I ran that on my little trivial dispenser model, I got this failing test. In the prefix, you don't have to do anything. In the parallel branches, you need 2 processes. You can call ticket twice, and sometimes they'll both return 1. No possible interleaving, right? There's no order in which you can perform those 2 calls that will make the post condition say yes when the answers you got were 2 1s. And the reason is that I wrote ticket like this. I implemented read and write, and there I called it that way. Is there a raise condition in that code? Let me see. Yes, I think we recognize that one. Okay, so let's apply this to dets. Dets is a tuple store. So each table contains a collection of tuples, one field of which, often the first, is the key. insert new is like insert, except that if any of the keys is already present, then the insertion is cancelled. And a few more. Actually, quite a lot more, actually. But as you can see, they're semantically very simple operations on the table. How can we model the state of the dets table? It's enough to use a list of tuples. Almost enough to use a list of tuples. And then it's easy to define what the behavior of all of these operations should be in terms of that list of tuples. Where's the code? I'm not going to show it to you. But it's less than 100 lines. I should admit, I didn't test all of the API. I just tested a part of it with many of the important operations. The dets code is a number of modules that add up to over 6,000 lines. So we have a pretty good ratio here. I'm not claiming 60 to 1 because we didn't test all of this code. But it's a pretty good ratio even so. Okay, let's run some tests. If I can find my Erlang. Here we are. Now. Note, this is R13. Just so you don't feel worried. Here, I'm running sequential tests based on a dets model. And as you can see, they all passed. What that tells us is that my model is consistent with the actual behavior of the code, or with the sequential behavior of the code. Otherwise, if I didn't do this, I'd make mistakes in the model, of course, and then I wouldn't discover anything useful. Let's run some parallel tests then. That's how easy it is. We found the first bug. And now it's going to shrink it down. These tests are a bit slower to run, that will take a bit longer, but we don't have to wait, we can go back to the slides. So, I wrote a small model of dets, and as soon as I started running parallel tests, I started to see errors. What did I see? Here's the first bug I found. In the prefix, if you open the file, and then in parallel, you do an insertion of an empty list of tuples. That's a no one. And an insert new of an empty list of tuples. That's a no one too. Then there's no possible interleaving of the results. Wait a minute, but they both returned okay. What's wrong with that? Problem with QuickCheck? Maybe problem with the model? Here's what the documentation of insert new says. Look at the result type. Boom! It's returning okay. So it's supposed to return true or false. And in sequential tests, it always does. But when you run concurrent ones, it returns okay. Where does that come from? Here's another one. Look, if you open file, and then in parallel, do an insert and an insert new of the same tuple, sometimes the test times out. I thought, why is my test timing out? Have I done something wrong? But at the same time, this message appeared. So I thought, aha, probably the bug is not mine. Okay, I decided at this point that insert new simply didn't work, so I took it out of my tests. And so I found this one. Here, we open the file, and then in parallel, we open the file again. You're allowed to do that. Multiple processes can open the same dets table at the same time, no problem. At the same time, there's a sequential process running, which inserts a tuple, 0, 0, and then gets the entire contents of the table. Here are all the tuples of the table. The empty list. But I just put 0, 0 in there. What happened to it? Okay, so I found these bugs really very quickly. And I sent them off to Linda, and I finally showed me what was happening. Dets runs a dets server that receives requests, and it processes them and sends off the answer. Here's another one. But of course, in concurrent tests, while that request is being served, some more requests may come along. So what happens when that operation is finished? You might think No problem. You know, we just take the next request from the mailbox, serve that one too. What can go wrong? You could do that, but it will be slow. And since the early 2000s, that's not what dets has done. Oh no, it's taken all these messages out of the mailbox, had a look at them, and figured out, look, these ones can go in parallel. And so it's grabbed those, started serving those requests, and sent them off. Ah, now we see that requests are being reordered. They're being executed concurrently. There's scope for things to go wrong. And we can begin to see how come those weird behaviors that appeared in the tests, how come they arose. Okay, so Hasse quite quickly was able to find and fix these bugs. But we suspected that they probably weren't the bugs that have been appearing in Klarna because they didn't have the same symptoms. The symptoms of the Klarna bug seemed to be that the file was being corrupted. So, we simply changed the property we were testing a little bit so that after running the parallel test and checking the results, we made one more check of the file just to make sure that it wasn't corrupted. And I started running those tests and on the corrected version of the code. And what do you know? Found another one. Look at this. I want to emphasize now that this is a minimal example. Take anything away from this test, and you'll get a test that passes. So what do you have to do? First of all, in the prefix, you have to open the file, close it, and open it again. I saw it. I thought something's wrong here. If I take away the first open and close, it'll be the same, won't it? No, it's not. The test starts with a non-existent file. This open creates the file. We close it. This open opens an existing file. It's different. And it leads to a different state in the server, and that's essential to provoking the bug. Then, in parallel, we have to do three things. A lookup, P0, and two insertions. In this case, it's two identical tuples, both of which contain a 0. And all the results are okay. But when we check the file for corruption, we got a premature in the file error. So that was nice. I was really excited about this. I was giving a talk at a developer conference, and I decided that instead of talking about what I promised to talk about, I would show these examples. But I hadn't kept the output from QuickCheck, so I had to just rerun it to regenerate my failed tests. And when I did that in my hotel room, you know what? I found another one. Here we are. You open the file, you need something in the table for this one. T10, let's say. And then in parallel, you reopen the file again. Ah, we've seen that before. And you do a lookup and a delete. Look up something that's not there, delete the thing that is. All the answers are okay, but when we check the file for corruption, we get a bad object. Here's what Tubba said on that mailing list 4 years ago. We've got bad object and premature EOF every other month last year. Here are two tests that provoke those errors. So I sent these reports off to Hasse as well. And every time, within a day, he found and fixed the bug. So we think now that they look as though they could be the bugs that appeared in Klarna. And we've now got quite strong evidence that they were the bugs that have been appearing in Klarna. Since Klarna began running the fixed code, I think a bad object exception has appeared one time in a file that is believed not to have been touched since before the new code was installed. So it got to the point where these exceptions were happening every week, and now for several months, they seem to have gone away. So there's good evidence that these really were the troublesome bugs. I just want to reflect a little bit on this. How come the bugs weren't found earlier? It was not for lack of trying. I know that Hasse himself spent at least 6 weeks trying to track these bugs down. seemed to happen when the files were around 4 gigabytes. Or was it 1 gigabyte? I think it was 4. Maybe it's to do with the rehashing that kicks in occasionally. So, if we were trying to analyze what was happening, speculating, it looked as though these things could be the problem. But now we know that it works with a file with 1 tuple in it. And, you know, there's certainly no rehashing. So, these speculations were completely off the wall. What does that show? It just shows how very, very difficult it is to diagnose a race condition from the symptoms that you see in production. Because by the time the race occurs, so much irrelevant stuff has already happened that finding the little bit that is responsible for the failure is vanishingly difficult. So the other question is, why weren't these bugs found in testing? Dets have been in production for many years. It's a well-tested piece of code. How come they hadn't already been found? I think that relates back to what I said at the beginning. I showed you that unit tests for races are hard to write. If something is hard to write, what are people going to do? Not write it. So my guess is that there simply weren't very many tests for race conditions in the dets test suites. And if you don't test for something, why should it work? I think another important point is that races are by definition some kind of feature interaction between 2 or more things that happen concurrently. Unit tests are okay for single features, but people write them to test 1 feature at a time. There's a good reason for that. If you've got n features, you're going to have to write order n tests. If you're going to start testing for feature interactions, 2 features at a time, you're going to need n squared tests. 3 features. Think of the premature end of file test. That had 3 things concurrently. Now you've got n cubed tests to write. It's not practical to write so many unit tests. So I think you simply can't test for this kind of problem by writing tests by hand. So that's my conclusion. The right way to find this kind of race condition is not to wait until production and hope that, you know, they'll appear and you'll track them down somehow. It's not to write test cases by hand because you can't. You can't write enough tests to hit the ones that will cause the problems. The only way you can find this kind of failure is to perform unit testing. You know, we tested the dets module in isolation with generated tests. And that's my conclusion. Questions? Yes?
How much time did you invest to actually get to that point? Yourself?
Yeah, if I had known I was going to write a paper about it, I would have kept track of that. So, I spent maybe building my initial model would have taken a few hours of work spread over a few days. And that involved also discovering my own, reading the documentation of dets, discovering my own misunderstandings of it, which meant that I initially wrote the wrong model, ran tests, they failed. I had to figure out, is this a fault or is it my fault? Correct the spec until I had a spec that really did reflect the intended specification, and then I could start discovering these errors. But yeah, maximum of a couple of days in total. And then the other tests, as I discovered more and more bugs, then there was an email interchange between me and Asperlin, who was sitting in Stockholm. And every time he sent me a new version, when I had time, I'd install it, I'd run QuickCheck again, I'd get another failure, and then I'd have to compose an email and send it back to him. But not very long. Much less than 6 weeks. And what's more, these few days of work found bugs. Anyone else? Yes? crude method compared with the other tools that we've heard about today. The good thing about it is that you can apply it without even having the source code of what you're testing. It always works. All you need is at least 2 cores in your machine. If I ran on a single core machine, the test would never fail. But with at least 2 cores, then you can just repeat the test a lot. It's crude, but it works.
Why do you do the 2-core machine?
Because on a single core machine, the Erlang scheduler is very deterministic. And we're then relying on maybe the preemption strikes at exactly the wrong moment. On a dual core machine, then concurrent Erlang processes are actually running concurrently. And you will get bad interleaving sooner or later. And as you saw, it didn't take very long to hit it.
So it's very nice that I did not change my laptop for 5 years and have a single core, so I could actually need to have another tool to actually find it.
Yes, that's lucky. We have run this kind of test on an 8-core machine. Oh, it's great. Things fail immediately.
Things fail immediately even on a 1-core machine. You can take control of the scheduler.
I know, yeah, indeed. But the reason that I didn't use that, and I could have applied Pulse to this, but it turned out not to be entirely easy because Pulse is a whole program annotation. And that means that if annotated code talks to unannotated code, it's not going to work. And dets talks to processes that start up when the VM starts up. So if you want to annotate it, you've got to annotate all the code running in the VM. So even the code loader, wait, I need the code loader to load my test. How am I going to make this work? It's actually quite hard to do. Just running on a multi-core, you don't have to worry about any of that stuff. I know that it's a limited method, but it's simple.
Who tells you when you don't know what the bug is? Where the bug is? Perhaps it's in the code.
Who tells me where the bug is? Has somebody in there?
No. Who tells you that the bug is not in the interaction of something that you are not testing?
You mean the bugs that were appearing as Clara? How do I know that they are these bugs? So, I don't know directly, but the indirect evidence is that since the code that corrects the bugs that we're found to be running, which was before the summer, then the errors empirically appear to have disappeared. And since they were occurring every week before that, then it would be quite unlikely that they're still there.
Scott?
Costas, I think you should get a new machine and just compile Erlang to disable SMP support. That's what I think you should do.
New telephones.
That I should get a new machine, I know for a while now, but I can tell you offline why I have to build a new machine. Because it's not so interesting for the rest of the audience, I guess. I actually agree with John. Testing is very important, and I think no single way of testing is good enough for everything. Okay, so of course you should start by testing the simplest possible ways that you have, and the ones that require less effort. And then you should go to, if you are serious about finding all the bugs in your code, you should go into progressively stronger methods.
Yes. So one thing that we know from experience is that as we get more and more cores in our machines, then race conditions become more and more of a problem. So that's the bad side. The good side is that as we test on more and more cores, it becomes easier and easier to make those tests fail. And that's, in a sense, that's a kind of disappointing result for a researcher because there's a scope for all kinds of amazing techniques to track these bugs down. So it's a bit of a shame that it actually works quite well just to repeat the tests on a number of cores. But nevertheless, I'm not ashamed to do that. Patrick, you had a question?
Yeah, I was trying to hard estimate the answer.
easy.
Hoping for another one.
So, of course, you need to be familiar with libraries to understand how QuickCheck works. But the code that I wrote, I was writing list functions to emulate what insert does on a dets table. It's like one line of code. These things are not complex. What I did do was I was quite careful about which operations from the API I chose to include in my model. And some of them, like insert and delete and so on, there's a function on the lists line that does the same thing. It's dead easy. Others, like match object, when used to create an incremental traversal of the table, then you start having to think about questions like, what happens if I start a traverse and then somebody else does some insertions and deletion while I'm traversing? How do I characterize what I will see when it comes out at the far end? And at that point, you start having to think much harder and to make to get a deep understanding of what the code is supposed to do. What about safe fixed table, for example? Do you understand what that does?